Good afternoon, everyone, and welcome to the latest WasteBuild 365. I'll give everyone a few minutes to join at this particular event, but we're going to be talking about how circular construction can tackle climate change. Okay, so let's give everyone a minute or two to join the event. As I say, this session is about how circular construction can tackle climate change. In a moment, I'll be introducing you to our panelists. But first, I wanted to thank you again for joining this latest WasteBuild 365 and give you a bit of a steer and some information on what else you can do within the event. Most of you, or a lot of you, have been contributing to the chat function. Now, that's available throughout the event, and you can send messages to the entire event or to the stage that you're in, or if you're in the expo area, to the specific booth that you're visiting. The whole point of this chat feature and of the ability to reach out to people directly is to really encourage that interaction. And so I'd recommend and I'd advise and I'd ask you all to start building on those networks that we already have and that perhaps we've been struggling to grow over the last few months during this lockdown by, as I say, reaching out to people, be they attendees, be they speakers, with a direct message, with an ask to have a video call during the event, and really just to spark up that conversation. Also, on your left-hand side, you'll see various rooms. Now, we are all in the stage, which is where the main presentations will take place. But you'll also see sessions, you'll see networking, and you'll see expo. Networking is a speed networking room where you meet people at random who are also in the event. There's a 2-minute window to chat with them. It's open throughout the event. And while there are downtimes in between main presentations, I'd, as I say, recommend you explore what's going on in the events, including that networking area and the expo area. And I think that's probably it from me to kick off this this first session. So, what is the next talk about? What are we talking about? So, as I say, it's titled "How Can Circular Construction Tackle Climate Change?" Now, with operational carbon accounting for about 50% of the building's carbon footprint over its lifetime, it's never just tackling operational efficiencies in a building and never going to get us to our net zero ambitions. And more than that, it's the embodied carbon specification choices that we make now that are going to affect how we reach this 2050 target, or more accurately, our 2030 stretch targets today. The embodied carbon that goes into our buildings now is what we really need to be making a change on when it comes to our decision making. And this is what we're going to be talking about in this session. We've got 3 leading experts from across the industry in various different guises who are going to contribute. We've got Edwin T from Arup, the multidisciplinary engineering consultancy. Now, Edwin is a senior structural engineer based in Amsterdam. And he's behind projects including the 100% circular People's Pavilion from Dutch Design Week back in 2017, as well as the brand new timber bridge in the Netherlands, which he can touch upon in his talk. We also have Panu Pasanen from, he's the founder and CEO of the lifecycle assessment tool Bionova, One-Click LCA. And lastly, but certainly not leastly, and our first speaker, who I'll hand over to in just one moment, is Simo Hakkarainen. Now, Simo is the business director from the Peikko group and specifically responsible for the Delta Beam Green solution that we and he is going to be talking about today. So, without further ado, Simo, if you can turn your video on, I'll pass over to you to begin your talk. Simo, over to you.
Everything fixed now. Can you see my presentation?
Perfect. We can see you.
Yeah. Thanks, Fraser. And on my behalf, also welcome on this virtual webinar arranged by WasteBuild. We are happy to be also in on this event, and this is really nice topic to talk about. And under this, how can circular construction tackle climate change? I will introduce today Delta Beam Green and how to lighten buildings' environmental footprint with that. So my name is Simo Hakkarainen. I work as a business director in Peikko, and later on after presentation, here's my contact information, and I will be hosting also our stand, so you can meet me over there today to talk more about the topic. shortly about my session time frame, I will introduce why we need to make actions towards circular construction, how to make concrete actions that direction. Then practical, how to lighten environmental footprint with Delta Beam Green and Delta Beam Slim Floor concept, and what does it mean in practice, some practical examples. In Peikko, we have a customer promise. We promise to make build industry, our customers, to be more efficient and more sustainable in their processes. And our aim is also to be global forerunner in slim floor structures, which I mostly talk today, and also precast and cast in situ connections and wind energy foundations. And we are operating more or less globally, more than 30 countries, so you can contact our local offices as well. So about the background, all we know that urbanization will accelerate and we will double the amount of buildings. It's been estimated we'll double the amount of buildings over the next 4 decades on the globe. So the amount is massive what we will build up in the future. It can be concretely expressed that we are constructing equivalent of New York City every month for next 40 years. So the amount is huge. And that's why we in construction industry, all the stakeholders, we act a really important role leading the change toward more sustainable build environment in the future. In construction materials and solution business, where Peikko is also mainly doing its business, the CO2 emissions are massive. All the materials have their own challenges we need to tackle together. And that's why we also in the construction material industry, we act an important role leading the change toward more sustainable buildings in this environment. Here are some of the report from the UN emissions made on 2019 of the exact figures, but the amounts are huge, so we can make a big impact. Then we need to look more detailed about the construction process itself. As Fraser mentioned, there is a development, design and construction phase, and as well the operation phase. So all these phases needs to have actions toward reducing these CO2 emissions. It's estimated that 30% emissions are generated during the construction phase, which is a lot about the materials what we are using, and 70% how the buildings is being operated in its operating phase. But we need to put attention on all of these. We are doing mainly frames and floors inside the Peikko, so that's why we need to look upon that. And what are the main ways to lighten environmental footprint with the building by the frame? We can, of course, expand the building lifespan with flexible space layouts. We can increase the cubic efficiency with the slimmer floor structures, that we are not using the space just for the structures, we make them more effectively. We can also improve the usability with having less vertical components like columns, etc., walls. Then finally, what I'm mainly talking today is to enhance sustainability with recycled materials and effective material utilization, which is also one of the biggest or the greatest impact on this construction phase. Then we are talking about Delta Beam Slim Floor structure, what that is about to meet these challenges. With that, we can offer additional room height when we are integrating the beam inside the slab system and enabling lower heating and cooling costs and CO2 as well on operational stage. Less need for columns as mentioned, space saving installation. In addition, it offers for architecture more freedom and it's fast and safe to erect. So these are the basic values that we can offer for our customer with Delta Beam Slim Floor structure. But that was not enough for Peikko. We wanted to steer our actions more towards circular economy also in the material point and in the product point. And that's why we generated Delta Beam Green concept, which I will present today. And our aim was ambitious to reduce the CO2 emissions significantly during the construction phase materials. And of course, eventually the materials will come back on this circular economy value chain and end up with the new beams to be produced. So what does it mean in practice? In Delta Beam Green, we aimed higher in the waste hierarchy. We started to use more than 90% recycled steel in all of our beams. So the material that is being used is recycled. it's using less of the virgin steel material compared to traditional solutions, traditional delta beam, for example. In addition, the prevention and reuse is big part, and this is not only concentrated on delta beam green, but also in our production we are putting a lot of attention of cutting the scrap. And in delta beams we can reduce the waste by utilizing it. For example, many times customers are asking where these web bolts end up, and we are using them in the floor joint. So this kind of effective material utilization near the value chain is important. In delta beam green, we are also using biodiesel in our logistics, so that's make a big impact, big reduction in the CO2 emission about the logistics. It's not only the production, but it's also how the way we deliver goods to our customer sites. That's we are doing with our partners in logistics. In addition, we have been changing our production energy sourcing, that we are using only renewable energy for producing delta beam green. And in addition, of course, as mentioned, Peikko is also part of this windmill foundations, and there is also a target for reducing their impact CO2 emissions by generating more effective foundation solutions for them. But for delta beam green, we are only using renewable energy for the production, welding, painting, heating, drying, all these processes. In addition for that, all these what we are doing need to be verified and proved, and that's why we have generated for delta beam green an EPD, and it's already shows that we can cut almost up to 50% of CO2 emissions compared to other solutions, and that's been verified, and this document can be found on our web page, and you can see the exact figures. Of course, it's always a need a detailed calculation based on project, but the figures are available and verified on our web page. Today we will hear more about that in Panu's presentation. And as mentioned, these EPD figures, they can be used then further on in life cycle assessments, generating the full result of the building's environmental footprint. And Panu Pasanen from One Click LCA Bionova will present more about this. We have been doing cooperation on that side, so it's important to understand details. Of course, other tools exist as well, and that's why our delta beam green exists in a databases to be utilized in your work. In addition for that, we know LEED and BREEAM rating. By using delta beam green, we can improve the rating for both of those options and reduce the global warming potential because we are using more effective ways. And then we have also generated tools to evaluate, because the floor is the beams are integrated, and there is the biggest impact we can make. The comparisons, for example, with traditional solutions like HQ beams, pre-stressed concrete beam, or delta beams, and we have get figures presenting this 50% cut on CO2 emissions by using delta beam green. That can be achieved by contacting our local sales units in Peikko for your specific project. So here is summarizing the delta beam green offering, the values it should offer for you as a customers, and we are more than happy to talk about these things in a future talks on stand or later on by your contact. Concretely, there is already projects ongoing. One in Norway, there is a learning center. It's already building is finalized. They were the first forerunners of using delta beam green, and the target was to have ambitious, environmentally friendly buildings, and delta beam green was part of that solution. And another project is in Finland, residential projects, where was a used the hybrid structures with concrete, timber, and delta beam used together, with also an ambitious reduction in CO2 emissions of the building frame itself. And more to come in the future. So let's generate together faster, safer, and more sustainable buildings, designing and building them with delta beam slim floor structure. And Delta Beam itself is already known system. It's been used over 15,000 projects in more than 35 countries, and we are hoping that Delta Beam Green will be also part of new successful projects with more attention on environmental impacts in your local countries. And as a summary, let's be part of answer to climate change, not a problem in construction industry. And more information on our virtual stand or our local units in Peikko, you can be in direct contact with me. And now I hand over this next to Panu. Is it so, Fraser?
Perfect. Yeah, that's thanks very much, Simo. If you want to stop sharing your screen, and yes, if Panu, you can come online and share your presentation, that'd be great. Thank you very much then for that, Simo. I'll at the end of the sessions, I'll wrap up the questions and I'll put them all to everyone once we're all done. So thanks again, Panu, and it's over to you now.
Yeah, thanks. So yeah, my name is Panu Pasanen. I'm from Bionova, who are the developers of One-Click LCA, and I'm going to talk about quantifying circularity. So what does it mean, right? So how do you know it's more circular than something else when you have to compare a number of options? And probably well known to you. So within Europe, the European Commission has estimated that construction causes about 50% of raw material extraction. So it's a huge quantity of virgin nature that gets, blasted away, smashed, and carried to building sites and to product factories. And what happens after is that we keep it in the buildings for some time, and then we put it back to landfill, or well, to backfill or landfill. And here again, we talk about massive figures. So Europe is not as big in demolition as some other locations, but the Commission likewise estimates that about 36% of the waste volumes would come from construction waste. So this is the problem. And the balance goes to some other applications, so it can go downcycling, so we make less valuable products from the raw materials that we used initially. We recycle them, especially if it's easily recycled and valuable material like steel or aluminium, for sure. We burn it, very easy to do. Doesn't matter if it's glued together, if it burns. And occasionally we reuse it. And not all of this is equal value, right? So downcycling loses value, recycling requires remanufacturing, and incineration is obviously one-way road. So not everything is like equally useful for environmental or material value preservation purposes. And that brings us to the problem as a designer or architect, engineer, whoever. How do you compare two options? Let's say one of them is timber, but it's supposed you install the timber elements so that you can't really reuse them, or you don't assume that there will be a market for them. The other would be, let's say, a steel solution. So you would be able to reuse them, but on the other hand, it's not biogenic. So which one is the better option from circularity point of view, right? And what kind of decisions you should drive? At the macro level, it's easy. You want to reuse more, you want to have more reused materials, but when you compare design options, you should be able to compare them across the whole panoply of different solutions you could possibly work with. And we are a software developer, right? So, and there was no good metric on the market. Nobody's come up with any measurement that's making any sense for circularity of a building. So unusually, we developed our own metric. Nothing fancy about it. It's material flow based assessment. So we are just looking at the total building mass. And we look at the value preservation in the end and the initial recovered content, right? In this building, we have 5.2% of the mass of the building recovered one way or the other from renewable and recycled sources in this instance. And then from the materials which are returned from the building, much of it is downcycled, some of it is disposed, and some of it is recycled. And this material flow analysis gives us the total score for building circularity. In our case, we calculated with a very simple formula. The building circularity is the average of the circularity of the materials that are used in the building and the average circularity of the materials end of life that are coming out of the building, right? And in the materials that are used in the building, everything that's not a virgin material is considered circular, and our renewable materials are considered circular as well for our purposes because, you know, they renew. And in the end of life, recycling and reuse are considered circular, downcycling and incineration are considered 1/2 circular. So it's basically an arbitrary weighting you could apply, of course, your own weighting, but our standard weighting is 50% because some value is retained, but obviously not long-term value. And what this gives us is basically ability to compare any two options, literally any two. So you have upsides and you have downsides between solutions. I think the Delta Beam Green is a great option. It increases the recycled content of the building. But when you use Delta Beam, it's usually it's often cast in place, right? And if you do concrete casting, you're pretty guaranteed to be destroying a lot of concrete. So you could compare a range of options. You could compare, you know, a standard solution, cast in place building with thick floors. You could compare a more material efficient one with Delta Beam Green, and you could even compare what you, in my opinion, should be aiming to do is dismantleable connections together with whatever are the best solutions, and Delta Beam is of course a good candidate there. So you could find a range of options, and you could compare them all in a quantifiable manner to be able to identify the optimum solutions from material preservation point of view. Why we have this approach is because, in our opinion, it's not sufficient to look at purchasing. At the same time, you should be looking at how can you design for disassembly and reuse to create a commercial market and commercial opportunity for reusing of whatever you have put in the building, and that you should leverage the strengths of the materials. Steel, of course, is much easier to disassemble and reuse than other materials classically. With concrete, obviously, you need to work a bit harder to be able to develop connections that you can undo. And with wood, well, currently there's an underdeveloped market for reuse of wood materials, but it's not something you couldn't do for sure. And the idea would be, crudely put, that you put garbage in and you get great products out. So your building product starts with upcycling products that you would make from something which would be waste or end of waste, as it is, or byproduct of another process. And you would be able to retain them in use for as long as possible, so that you would actually increase the circularity of the whole industrial system, as opposed to just buying the best possible products for yourself. So we are looking at this whole life cycle, and we think this is a very important approach for a designer. And how does it work in practice? Is that you need to have a bill of materials. It can be coming from Revit, it can be coming from, you know, anything. And it generates you automatically the circularity parameters based on typical properties of material. So if you use CLT, CLT typically has 9% glue or thereabouts, so you would have 91% renewable content in the CLT. If you're using steel, you know, if it's an EPD that you're using, it will have data about recycled content and so on. And every material has a standard end-of-life process if it's not considered to be handled separately. But if you apply design for disassembly or design for adaptability practices, you can change the end-of-life processes. In this illustration, we have steel recycling, you know, wood incineration, landfilling inert materials, concrete crushed to aggregate, and other end-of-life scenarios, which of course you, with careful design, can alter based on the design solutions you can identify to preserve materials in use longer and also beyond the current building life cycle. Important thing here is, we believe, is that the standard settings are generated automatically. So you don't have to start by thinking what would be the baseline, and then you can start to optimize from there towards whatever circumstances you need. The standard settings are different for countries within the European regulation system and non-European regulation system, because the waste regulations drive quite different amounts of landfill avoidance within Europe and outside of Europe. Obviously, the theme of today is, using circularity to reduce carbon. We know that, right? However, circularity and carbon reduction correlate many times. Also, they can help with cost reductions. So here I have an example where you have 3 different scenarios: basic building, more circular building, and more materials efficient building, which are compared for life cycle cost, life cycle carbon, and building circularity. The highlighted row here is the share of circularity of the building itself, which is increasing from left to the right. Top line is life cycle cost, which is also, which is reducing from left to the right, and life cycle carbon, which is also reducing from left to the right. So all of these correlate. And obviously, in this scenario, we do have energy consumption of the building in the scope. So the life cycle carbon would be decreasing faster did we exclude energy. But of course, to make life cycle performance optimization, energy is useful to keep in scope. And here below, you can see how the different options are stacking up against each other with the share of recycled content, renewable content, virgin content, and so forth. Just to put this into, or give a practical example of what this means, I'm going to be sharing the example of the office where I'm sitting, which is our new headquarters, which we renovated into an old industrial building. And I want to just share some very simple examples, which I think are good and which can be easily adopted when you work with this type of buildings. So in our renovation, we had to move a number of walls. And if we would have done it the classical way, we would have redone the ceiling, we would have redone the floors for the whole building, right? Or for the whole area we occupy. However, we didn't want to do that, so we just added detailing where we took out walls, which, either you like it or you don't, but it tells you that you have done something on purpose, and it of course saves huge amount of money and of material when you do so by just replacing, let's say, 2.5 meters of ceramic tiling as opposed to redoing hundreds of square meters of flooring. We also had all storage rooms, like nobody stores anything anymore. We don't have paper anymore in the office, well, to a meaningful extent. So we don't have need of those, right? But we do have need for video conferencing booths and phone call booths. So we created basically conferencing booths of all the storage rooms which were there. And again, to distribute daylighting better, we could have knocked down all the walls, but we actually created some internal windows to allow for daylighting. And with these, I'm quite proud of the outcomes. So we were able to reduce the renovation carbon footprint by a factor of 6 compared to a standard classical renovation. And we were able to increase the circularity score to 45% versus the initial 28%. And of course, if we were considering this to moving to a new building, which would have been an option as well, the saving would have been 30 times in carbon sense. So why I'm showing this example, even if it's completely different from the material specification, is that I think it works. It tracks the performance very closely. It's intuitively understandable. And we believe that it's understandable, makes it quite good. You need to understand what you're calculating to be able to rely on it for your decision making. If you didn't know about us before, so I'm happy to also mention that we are One-Click LCA. We are world's leading construction LCA software platform. We are providing the software to more than 70 countries. We comply with 40+ plus certifications, BREEAM, ANAL, BREEAM UK, LEED, whatever you work with. Every certification in Western Europe and North America, among others. We have about 96,000 LCA datasets for materials in the platform. We have 13 integrations, including Revit, Grasshopper coming soon, and Tekla Structural Designer coming next month. And we have 36 people right now, and we are in business since 20 years now, and are operating financially solid on a solid basis. We are happy to work with Peikko. We work with others as well. And the clue of our business is that we connect you with your supply chain, or we connect you with your customers. So you can share data, reliable data, and generate data for others to use. So when you're engineer or architect, you can generate drawings, designs, and quantify them, and then give that data to investors or builders. And when you're a manufacturer, you can generate EPDs and give that to architects, engineers, or builders who need it. And we also help a few institutions with their policies and regulations. Thank you very much.
Perfect. Thanks very much, Panu. Really interesting, and I think a lot of what you've said there resonates, especially with reference to your own building, your project, right? Really interesting, and a few points that we'll discuss at the Q&A stage. Thanks, Edwin. You turned your screen on. I can see you. Over to Edwin T then for the final presentation of this particular session before we hit the Q&A. As mentioned, do put any questions you have for any of the panelists in the chat box, and we'll cover those once Edwin's finished his presentation. And so, Edwin, over to you.
Thank you, Fraser. Thank you for inviting me to this year's WasteBuild event, and welcome to all the visitors. I'm Edwin T. I'm a structural engineer at Arup, and I have a 20+ years of experience in design of bridges and buildings, but mainly I'm a bridge designer, and I work for about 15 years now for Arup, and Arup is an independent firm of designers and engineers, and we're working across every aspect of today's built environment. Our founder, Sir Over Arup, he believed that work was only valuable when it had something higher to strive for, and that's something that really resonates well with me. We work all across the world, and we have about 16,000 staff members and counting. So I'm going to very quickly run through how circular economy can tackle climate change. To start with, I'm first going to share a quick overview of what is the actual impact of buildings, and then I'm going to talk a little bit about how circular economy can help to reduce your carbon emissions. So let's quickly start from a macro level. The share of buildings in the total global CO2 emissions is about 40%. So it's really a large part of the total carbon emissions globally. About 28% was due to the building operations, and 11% is due to the material production and construction, as mentioned also by the previous presenters. So when we very quickly look at a building, a typical building, standard building, you might see over the life cycle a 25% of embodied energy compared to the 75% of operational energy. But if you look at a high performance building, and that will only improve in the future, then it might be already 50-50, or even the embodied energy is the larger part of the life cycle carbon emissions. And if you think about if we build a building now, the embodied carbon due to the materials and construction is there immediately, while the operational energy will slowly over the life cycle of the building will increase. And when we look at the 2015 as a target for when Europe wants to be carbon neutral, if we build a building now, then still 80% of the total carbon emissions is 80% due to the embodied carbon and 20% due to the operation. So embodied carbon is definitely a significant aspect to think about now if we want to become climate neutral. If you split it a little bit more up then into where does the embodied carbon sit in a building, some studies done in the Netherlands by Metabolic, it shows that residential, commercial buildings, that the main structure, so the substructure and superstructure, make up more than half of the embodied carbon in buildings. So that's a really important aspect, and that's also the main aspect of structural engineers to have an influence on. More studies on the material flow in the Netherlands by Metabolic and STS Search shows also the material flow and what type of materials are the biggest impactors. And from that, you can relatively quickly see that concrete and steel are the ones that contribute the most in quantity and in carbon emissions to the total carbon emissions. So steel and concrete. If we look at a little bit more into the total environmental categories that impact, that have an environmental impact of the materials, a bit also like the tools that Panu described, we'll look at. If you look at all those environmental categories, then 65 to 75% of steel and concrete are shared by the global warming potential. So that has all to do with the carbon emissions related to the production of those materials. As I said before, my main job is a bridge designer. Differently to buildings, bridges generally don't really have a lot of operational energy. It's predominantly embodied carbon due to the materials. Operational carbon would most likely be limited to lighting on a bridge. And also within the bridges, there's mainly the two elements, the two materials, as I mentioned before. Steel and concrete are the ones used in 95 to 99% of all the bridges. Therefore, we also now being commissioned by the Dutch Highways Agency to do a feasibility study to look into the use of timber for bridges, highway bridges. So I would say my message would be we need to reduce the embodied carbon urgently if we want to tackle climate change. And I would be a big fan of more stricter legislations that will introduce a kind of carbon target for the structural embodied carbon to a kind of descending level to 2050. And it's a bit ambitious, but I hope that is something that we are slowly going to with the new Green Deal. It's quite positive, the ambitions of the Europe region. So what's the impact, or what can circular economy do then about this? Well, circular economy is based on about three principles. First one, design out waste and pollution. Second is to keep products and materials in use, and thirdly, to regenerate natural systems. So all these three principles all have their impact on reduction of greenhouse gases. So the design out waste and pollution is there to reduce the carbon emissions, mainly at the start of a building, so the embodied carbon. Keeping products and materials in use is there to retain the embodied carbon, and regenerating natural systems is there mostly there to capture carbon out of the air and store it in the soil or in products. So it has a circular economy is a really good tool, a means to tackle climate change. As a designer, you then want to translate that into kind of design principles to be used when you're designing a building. One of them would be to use low carbon materials, like we're doing at the moment for 37 meters or 73 meters high residential tower in Amsterdam, which is mainly made out of timber. Only the lift shafts are made out of concrete. Another good design principle already mentioned by the previous speakers is to be material efficient. So either we can use, for example, high strength steel compared to normal strength steel, which can then reduce the amount of steel that you need. A very good one is also to repurpose what we have. We have a huge amount of buildings already being built. It would be a shame to knock them down and build something new. So repurposing old buildings is a really, really good way to keep products in use. Like, for example, this picture is about the Lokhal in Tilburg, which was an old rail depot, which is now being completely transformed into a huge space with a lot of cultural programs in it. Another really good principle is the design for future disassembly, which an important aspect of that will be to design it with reversible connections, so you can disassemble it easy without losing value of the original material. The two pictures shown here is the People's Pavilion that we designed for the Dutch Design Week in 2017. It was completely built with reversible connections without any damage to the original material that was borrowed, and we had to return it. So whoever wanted to borrow it, that didn't want to have any damage to their material, so it can be reused to the highest value. On the right, you can see the disassembly picture of all the materials before it went back to the suppliers who borrowed it to us. And another really good one is to capture carbon into products. So capture the carbon out of the air into biomass, and we will then can use that then to make products from, for example, flax or hemp, or as mentioned previously already, timber. So I would say we really need to start now with reducing our embodied carbon footprint if we want to meet the climate goals of 2050. And Aero can, of course, help you deliver on your ambitions. Thank you very much. If you have any questions or anything else, you can always contact me on this email address, and I'm happy to talk to you about that.
Perfect. Thank you very much, Edwin. Really good presentation, and yeah, we've had a few questions coming in requesting copies of the slides and recording. So if you're happy, it'll be great for us to facilitate that for everyone afterwards. If the other speakers can turn back on their video and audio, we'll just come back to a bit of the Q&A portion at the end. I've noticed we've been dealing with some of those questions as they've come in, which is great. I'll just kick off with one a general point for everyone. We've overrun slightly on the timing, but that's fine. And it's with regards to the extent to which we're seeing whole life analysis as being an important, or how important is it today in the whole kind of specification process and building design process? How important is it currently, and where are you seeing that as we move forward in the next 5-10 years? I don't know if Edwin, perhaps you want to kick off with that as the engineer, the importance to which this is factored in now, and then we'll go around the panel.
Well, as I showed, the importance of the embodied energy and the total impact of our buildings and bridges is really large. We can see a good trend of clients, governments to kind of be more aware of the circular economy, see the benefits of circular economy. They're setting up their own ambitions to reduce carbon, to work more circular. As I mentioned before, the Dutch Highways Agency is a really ambitious client who already wants to be climate neutral and work in a circular way in 2030, so in 10 years' time. So we really need more clients like that who have those high ambitions to get to accelerate the transition.
So it's client driven in your experience.
It really helps, but I don't think it's just client driven. I think the whole supply chain has a responsibility here. Of course, regulations are in that sense easy to force people to do things, but I think we all have the responsibility to look after the planet. Yeah.
And Simo, perhaps from your perspective, again, are you seeing this as being an important part of what you're doing with Delta Beam Green?
Yeah, I think this, for example, importance of as a producers of materials is like this importance of EPDs is coming. We have been having those for 2014 ahead, but now the inquiries from our customer side is increasing, and it's a way to prove what you are doing and verify, and that's the importance that we have noted for. And of course, what you measure, you get with these EPDs, then your targets become more ambitious, and this is the change we have noting for previous and recent times.
And Panu, from your position, you'll obviously see, presumably you're seeing this grow exponentially year in, year out. What are you seeing at the moment?
Yeah, so we have seen it takes about a decade to become mainstream in our country. And so you need a leading client like the Dutch Highways Agency or Stadtbygg in Norway, or high speed do in the UK or anybody, right? Who puts a lot of money, a lot of focus on this, and then makes everybody learn it, and then people pick it up over years, and we can't say it's mainstream yet fully everywhere, but we can see that it's very hard to run a successful business anymore in the UK or Nordics if you can't do this well. Same in Netherlands for sure, and France is getting that to that point as well. So you can't like avoid it anymore. Whether it's the driving factor for decisions, for sure not. Capital cost and life cycle like profits will be still a dominant factor, but that the discussion is happening on this aspect at all is important. And then of course everybody will try to optimize within the financial objectives they have and the sustainability objectives they have.
I think that's a really valid, really important point as well, actually. And we've each kind of touched on it in a couple of the points you've mentioned. There is this legislation sort of piece, I think, that's a kind of the stick. We must be doing this, and we're going to enforce it. But I think there's also an important point around the kind of the financial and the business case for this, and it's the point at which it becomes well, from a developer or a client's perspective, actually this makes monetary sense to be employing this methodology and to be incorporating design for disassembly into our building. And I think it's this important thing about talking about it, communicating the benefits of doing so from the bottom line perspective, and that being realised by clients. That I think is obviously important as well, and that's what we're sort of trying to help with here. Just further to that, and something that I think Edwin you was mentioned with regard to this timber bridge that you're working on, and Simo, you mentioned it as well. That this hybrid approach where you're working with CLT or to support CLT. I mean, how important is this hybrid approach? And what, I suppose, briefly, if you can, Edwin, how did that timber bridge kind of materialise, and Simo, where does your kind of hybrid model fit? Edwin, perhaps first.
Yeah, the timber bridge. I think all credits to the client who set this himself this ambition in 10 years' time to work circular. And I think the really good part of that is that they realize that just by saying we want to be circular, you need a market to actually deliver on circular solutions. Like Simo was talking about the green beam from Peikko. It's like those are solutions if you want to get to a circular building. So in that case, the Dutch Highways Agency realized that they needed to kind of stimulate the market to come up with circular solutions. So they have an innovation tender for the market to come up with these circular solutions, even fund them a little bit to do this research. And I think that's a really kind of good of a carrot that's needed for the market to jump on the bandwagon for all of us to come up with these circular solutions. If you don't have circular solutions, you can still have great ambitions, but if there's nothing you can buy, then it stops there. So I think that's the kind of cooperation that's needed in the supply chain.
Mm-hmm. And Simo, just to finish off with that hybrid point around how you're working with timber solutions.
Yeah, actually, these hybrid solutions, they are also gaining ground on the markets, that you are combining steel, concrete, timber to take best part of those. So this kind of material neutrality towards the solution that is the best. And we have been adapting delta beam slim floor benefits together with CLT slabs, which bring certain benefits for customers. And that's I think the direction we are heading all the time. It is hard to say which one the materials is best from this CO, because I think none of those materials can solve this problem alone. And that's why we have been also being able to utilize, when you make a slimmer slab system, whatever it is, it might be also CLT, and then you can lower up the building height, make the technical installation easier, and this kind of argumentation. So it's like a general benefits of the building users should be taken. Is it wood? Is it concrete? That's secondary.
If I may add to that, a phrase around the hybrid part for the timber building in the Netherlands. The original ambition was to have a full timber building, but once we started to do the engineering. Like Simo said, you have to use the right material in the right way. So while designing the building, due to stability and stiffness of the building, it was decided that the lift shaft needed to be concrete for several structural reasons, and the rest we made out of timber. So so you have to use the material for its best assets in the right way, and I think that's important.
Yeah, right material for the right reasons.
Timber's not going to be the solution to all your issues. It's not going to take over concrete or steel or anything like that. So it's a nice additional material to be used.
Okay. Apologies if we've not got to your questions. Obviously, Thomas and Stan, you've put some things through, so apologies we've not got to those. I'll ask the panel to come back to you on them after the event. We've unfortunately run out of time for this session. Just leaves me to say thanks everyone for engaging with it. Thanks to all of our speakers for taking part and presenting. I'd encourage you all to reach out to them directly if you've got any further questions, and likewise visit the Expo area where Peikko have a booth on there. You can watch a little video on what they're doing, and also, as I say, reach out to Simo throughout the event. The next session coming up in probably about 20 minutes is on the main stage is about the Green Deal call. So do join us for that one. So it just leaves me to say thank you once again to all of our speakers and you for watching and engaging. And yeah, I look forward to the next session shortly. Thanks everyone. Speak again soon. Bye bye then.
Thank you. Bye.
Thank you.